Welcome to Csec Biology TCP. I am Mr. Wilson from the TCP Academy. You can find us online at tcp-academy.teachable.com. Today we're going to be looking at line transit, as it were, for the CXC syllabus. This is a practical that must be completed by students who are sitting the CXC examination in all 16 territories. Let's look at the line transit as to what it is, when it is used, after which we're going to be looking at it being used. So the distribution of organism is affected by both biotic and abiotic factor. Last year, many students differed on their CXC exams as they were afraid of failure due to their level of readiness. This year, Mr. Wilson and his experienced team from tcpacademy.teachable.com is here to help you get exam ready. Subscribe for free to tcp-academy.teachable.com. We offer courses in CXC Biology, HSB, English Language, and many others. There are several offerings to each course. Enroll in one today. The Transect helps to provide an idea on the distribution of organisms, species present, and how they change across the habitat. Now, these are three salient points that we must remember once we are talking about line transit. The distribution of the organism, the species that is present, and how they change over or across a habitat. The change across the habitat is called zonation. The Transect does not give abundance nor the number of organisms in the habitat. It tells about change. So please bear in mind the Transect line is not used to determine abundance. A kite diagram shows the number of animals or percentage cover of plants along the length of the transit line. A transit line is simply a string or tape measure that is marked at defined or regular interval with a specific scale. It could be a meter, more or less. It is usually extended on the ground across the habitat or part of the habitat where there is a transition or change in the organisms or the habitat. It is properly used across rocky seashore or across landmass to sample stationary, slow-moving organisms or plants. The organisms touching the line transit are usually sampled for CXC, or we could look at the organisms that are above the line, below the line, or to the side of the line. Now, these are usually recorded as part of your observation. The position of sample, wherever you're going to read, is supposed to be defined before the sampling is done. That is very, very important. Are you going to read that which falls below the line, that which falls to one side of the line or two sides of the transit line, or touching the line, or those that are above the line? This is a decision that the person is doing the sampling must make and define in the research. This here represents a kite diagram, and the line in the middle here represents the transit line. Now, the transit line has a scale pretty much in meter. So it goes up from 0, 5, 10, 15, 20, 25, so on, 30 upward. Now, what we're seeing happening here is that as we move away from the point called the origin, so we are sampling from this point, and usually we are sampling from a point that is called the origin, as we know pretty well that the distribution of the organism is going to be affected by biotic or abiotic factor. In most cases, using the line transit, the organisms will be affected by abiotic factor. So we are going across here, and based on what this kite diagram is showing, is that both sides of the line transect up to about 10 meter, we are having somewhat a significant increase in the number of organisms from 0 to about 10 meter. When we get to 10 meter, we are seeing on both sides of the transect that the number of organisms are dwindling down to a point of 0, and then soon thereafter, it starts to go up again and then down eventually. Now, the line transect is best used with other equipment that measures abiotic factor. We could look at the salinity of the soil. We could look at the light intensity. We could look at the pH of the soil. We could look at the humidity of the environment. All these could serve as factor to cause the population to increase or decrease. The kite diagram is not so much for CXC, but looking at the kite diagram, it helps us to form a good judgment as to what's happening with the population. Let's look at the line transect as it were in our local situation. Now, the line transect here, for simplicity, it is tied to two flagpoles, red and white flag, and pole here. Our interest here is to look at the distribution of the organisms along this transect line. Now we're looking at the distribution of the organism pretty much from this mango tree, which forms a shaded area here. Now we can see the line going across, and for each bond, yellow or brown represents a meter. So 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, 6 meter, 7 meter, 8 meter, 9 meter, 10 meters, that type of a thing. Or a teacher could apply a multiplying factor to the meter. Based on what we're seeing, as we move away from origin, about 1.25 meter, we're finding organisms that can manage the shaded area. There's no organism under the mango tree. However, when we move about a meter just to the edge of the canopy of the mango tree, we're finding some green plants that are well established. But as we move away, we realize that the type of plant in the area is changing. So we are seeing some plants that have white flower closer to the green, and then we're seeing some yellow, purple, and so on. But you're seeing that zonation here where we can say that the green plant is somewhere about 2.5 meters. It occupies about 2.5, 3 meters away from origin. Then we are seeing the white plant, right? So we are talking about origin moving from this mango plant here, moving upward. We could also say that the condition for which these plants prefer changes over the area of transition. So you are seeing a transitional area here. You're having green and white, and then a yellow and white, and then we transition over to purple and yellow, and then eventually purple. So you are seeing that clear demarcation here. That is what the line transect does. It shows you the distribution and tells you about the type of organism that is there, but it's never really tell you about the abundance of the organism. The line transect is always read from the point of origin. And in this case, we are moving from the origin outward into the sunny field. And we can say that what is happening here, there's some change. And this change is as a result of something that would have been better tested if we had other equipment to measure abiotic factors. So some of the things that we could look at is light intensity. I would need a light meter to determine if light intensity with the green plant is the same as the white, yellow, or purple. Now, a light meter would help us there to see if light intensity is affecting the distribution. We could use a pH meter to measure the soil to see if the pH of the soil changes over the area of sample. We could also use a thermometer to find the temperature of the soil or the temperature of the environment as we go through the zonation or the transition landmass that is sampled. We could also use a hygrometer to look at the humidity of the air. That's the amount of water vapor present in the air. That too could impact the distribution of the organisms in the particular area sampled. We could also look at the moisture level of the soil. To do so, we'd use a simple moisture probe that is pretty much immersed in the soil or pretty much placed in the soil to gather the information as to the amount of water that is available in the soil. So when we use the line transect, it shows us, as we're seeing here, how things change over a landmass. It shows a transition clearly. It also shows us the type of organisms that are present. This could be enhanced if we use other instruments to check for abiotic influence on the distribution of the organisms. The information garnered from the Transect line can be recorded in a table. So for example here, distance from origin. We could look at the distance from origin here that we are finding the purple plant. So that could be pretty much documented in your table. Be reminded that your table is supposed to have a header that is descriptive of what is in the table. You could look at the type of organisms. As it were, for this sample, it is going to be with green, yellow, white, or purple organism. That is what you're going to be documenting in the table. You could look at the numbers that you're finding touching the transit line, but that will not tell you about the abundance of an organism in the area. To look at the abundance, we would have to look at the transit line being used with a quadrant. We could use a transit line with a quadrant to one side or to both sides, as it were, when we are looking at the kite diagram. That would have brought us to the end of the transit line. I do hope that we provided enough information for you to master this journey if you were supposed to look at the transit line or use a transit line in an exam, and to, of course, answer the question like some of the factors that would have influenced the distribution of organisms. I am Mr. Wilson from Csec Biology, TCP. You can find us online at tcp-academy.teachable.com. You have just watched how to use the line transit for CXC Biology. Remember to like, share, subscribe, and leave us a comment. Thanks for watching. Last year, many students differed on their CXC exams as they were afraid of failure due to their level of readiness. This year, Mr. Wilson and his experienced team from tcpacademy.teachable.com is here to help you get exam ready. Subscribe for free to tcp-academy.teachable.com. We offer courses in CXC Biology, HSB, English Language, and many others. There are several offerings to each course. Enroll in one today.